So just as a reminder, everyone should have a piece of paper out and be ready to go to page 144 when we're done with that. I'm recording that. Extra credit tomorrow I told you about. Make sure your pink sheets are with you. If you don't have the pink sheet on that day that I'm checking, or if it's the formula sheet and it's not complete, it's not extra credit, okay? My extra credit's pretty easy. You just have to have the stuff in your folder, okay? So, all right. What we are going to do today is take what we learned yesterday a step further. But before we do that, I want to take care of some common mistakes I see. And again, open note quiz, it'll be nice to have all these things right in front of you. So when you get to some weird fraction, you're like, how do I deal with this fraction with words in it? You have a place to go look for it. We're going to put all the common mistakes in one place, right? And we talked about a little bit of this yesterday. Okay, and this is our first one. Sometimes we have to split up these, what I call big fat fractions. Like this is one fraction with two different numerators, right? They're just all huddled together. And sometimes in these problems we learned yesterday, it makes sense to separate the fractions, decompose, if you will. So one thing you should think about is that if there's a subtraction in the numerator, that means to get to this step, they had to have a common denominator. So this would have been 1 over sine x minus cosine x over sine x. And you'll see me put this like reverse arrow in the problem. And that's so that you guys can check it in reverse. Sometimes we're like questioning ourselves. I do it too. Like I'll look at that and be like, wait, are these the same thing? Because it has to be the same thing. And so a way to check it is in reverse. Like if I gave you these two fractions and I said make it into one, combine them, you'd say, okay, subtraction has to have a common denominator. Okay, the common denominator would be sine x, and then I would just subtract my numerators. Okay, so that's a way of like making sure you did it right. This one's very similar to it, but there's a common mistake I've seen students make. Okay, common mistake. So same idea, guys. This is addition. So if you have addition or subtraction in your numerator, you had to have a common denominator to be able to add them or subtract them together. So this one would be 1 over sine x cosine x plus cosine x over sine x cosine x. Check it in reverse. If I told you, if I gave you what's in green right here and I said combine them, you would say, okay, addition, I need a common denominator. Yay, my fractions already have a common denominator. So when I put them together, I would have sine x cosine x as my denominator and add my numerators. Anybody have an idea of what the common mistake is that students would make on this type of problem? No, that's not what I was going to say. That's, yeah. Thank you. Yeah, they'll split the sine and the cosine. For some reason, they'll think, okay, I'll do sine x under this one and cosine x under that one. That's not what you would do. You would not get that answer. That's the way it is. Okay? That's why this backwards arrow thing I write is really helpful. Like, does this equal that? Okay? And then let's do one more of these. Here's another fraction. And what's different in this third example is that the numerator is multiplied together, not added. So you have to think when you multiply fractions, you don't need a common denominator. And in this case, you could have two different situations. You could either rewrite this as cosine over secant times sine, not over secant. I'll come back to that. Or cosine x times sine over secant. Either one of these. But notice what's going on there is secant is only written once. Again, in reverse, if I gave you like this one right here, you'd say, okay, I'm multiplying two fractions. I don't need a common denominator, so that's a 1. oh, I just multiply these two together, multiply those two together. I would get that answer. Same thing with this one. This would have like a 1 under it, cosine times sine, cosine, cosine, sine. 1 times secant, secant. So how do you know which one to do? It would just depend on the problem. You could do either. Which one makes more sense in whatever problem you're working on. But the common mistake there would be to give both of them secant. But that wouldn't be true. Because if I had both of these had a secant, it would be secant squared when I multiply the denominator. So notice the differences there. Okay? Next, I just want to remind you of the Pythagorean identities. So important that you recognize them. They pop up all the time, including today. Starting with the cosine squared x plus sine squared x equals 1. That's like the one that starts everything going. That's like your basic Pythagorean theorem on the unit circle. And remember, cosine and sine can be switched. It's addition. So you can put sine squared first or cosine squared first. But we saw this yesterday. We'll see it again today, where sometimes in a problem you'll have this left-hand side, and you can get rid of that whole chunk of cosine squared x and plus sine squared x and replace it with 1. All right? And then don't forget, you can rewrite this 2 other ways. You can isolate the cosine, isolate the sine. So if I want to get cosine squared by itself, I would just subtract sine squared x from 1. And if I want to get sine squared x by itself, I would subtract cosine squared x from both sides. And remember, we use those Pythagorean identities a lot, where we are given one side of the equation and we substitute in the other side of the equation. These are facts, identities. These are true statements. So you're allowed to take whatever's on one side of the equation and replace it with what's on the other. Substitute. You do that a lot, a lot, a lot. And the last thing I want to review is some factoring. Three types, starting with GCF. Let's go back to algebra. In algebra, you would have had a problem like this, or like this. What I want you to notice is both of them have a minus or a plus in between. And so, you know how yesterday I was kind of trying to train you to look for certain things to help you know how to start a problem? GCF problems are very, very common. And the way you find them is you see a plus or minus between some stuff. And in that stuff, there's like stuff. Okay? Meaning, like in this first example, both sides of the subtraction sign have an x in common. That's my GCF. That's my greatest common factor. And all you're doing is the reverse of the distributive property. I'm dividing both of these by x. Whatever's left goes in the parentheses. And I would get 1 minus y. GCF. You've done it a million times. What would be the GCF in part B? 2. Yeah. Dividing both of these by 2 leaves you with x squared minus 1. And guess what? Sometimes you can go even further. That's the difference of 2 squares, right? 2 parentheses, 2 different signs. That's x plus 1, x minus 1. So we know how to do GCF types of factoring in our algebra math. And we've already done it back in, if you need to go back and look at it, in section 3.10, we did factoring with trig words. Same exact idea. I see a plus or a minus in between like stuff. Whether it's numbers, whether it's letters, whether it's words, right? Evan, you got the last one right. What do these two have in common? Sine. Sine x, yeah. So when I divide both of these by sine x, what's left over would be 1 minus cosine x. It's the same idea, whether it's numbers, letters, words. I just touched on difference of 2 squares. I'm not going to do this one again, but the algebra version of it, x plus 1, x minus 1. Got to be a subtraction sign. Both terms have to be perfect squares. We've done it with trig as well. Guys, anytime you get a trig factoring problem and you're confused by it, take out the word cosine and just make it x. Like this is just x squared minus 100. Factor it like that, and then wherever you see an x in your answer, slip a cosine in front of it. This is just the difference of two squares, which would be cosine x plus 10, cosine x minus 10. Just like we had x plus 1, x minus 1. One's a plus, one's a minus, square root of everything. Last one, quadratic trinomial, also known as a chart problem. Just do one algebra looking one, easy type. So in algebra, you're asking yourself, what two numbers multiply to get 1, add to get 2, which of course is x plus 1, x plus 1, right? Done. Two numbers that multiply to get 1 and add to get 2 would be 1 times 1. And then in trig, same exact problem, by the way. Really, you need to be doing my stuff. Same exact problem, B is as A. The only difference is I slipped the word sign in there. It's still just what two numbers multiply to get 1 and add to get 2, which are 1 and 1. The only difference in our answers is I'm going to slip the word sign in front of each of my x's. So sine x plus 1, sine x plus 1. So anytime you're confused with factoring with trig, take the word out and factor it as if the word weren't there, and then wherever you have the variable, just put that word back in front of it. Okay? So I would put this in your notes. I would have it nearby while you're working on the homework today. It might help you. But we're going to go to page 144. We have 4 examples to do. These are more challenging than yesterday's. You definitely want to pay attention, write these down. And I've changed the page a little bit. I'm going to call this guy A. And I have a C and a D for you. I'll give those to you in a minute. Let's look at A and B first. These are the hardest two. In fact, A is the hardest one. Okay? So I'm going to actually start with B. So do me a favor and get to that one. And so, guys, the hardest thing about these problems is knowing how to start them. Like, you're looking at it and you're like, I don't know what to do. That's a big part of getting comfortable with these, okay? So let's start with that. When you look at these problems, you first want to pick a side. I'm going to pick the left-hand side, more to work with. And in this case, I don't see any squares or minuses or, in fact, I don't see any like terms I could factor out. Let's go back to one of our first tricks we learned yesterday, and that was changing everything to sine and cosine. So I got a cosine, I got a sine, but I can change cotan to cosine over sine. So that would be cosine x times cosine x over sine x plus sine x. Okay? So you might be like, okay, what did that do? Let's see. What I also notice is that I have to somehow make this whole mess on the left-hand side equal cosecant x. One word. I have to make all of this equal one word. Well, when you have an addition symbol between stuff and you add it together, it becomes 1. So I'm going to make a plan right now that I'm going to have to add these together. Okay? To do that, though, first, I can go ahead and combine these two. These are multiplied together. I don't need a common denominator or anything. I can just put them together. That would be cosine squared x over sine x, right? That's just putting these two together. That became this. And if it helps put a 1 under it, go right ahead. To add fractions, I need a common denominator. Looking at your denominators there of sine x and 1, what would the common denominator be? Sine x, right? Sine x. So I'm going to make a fraction with that goal in mind of putting these together under that common denominator. And then I'm going to take each fraction one at a time. So looking at that fraction, it already has the correct denominator. I don't need to do anything to that fraction. I'm just going to bring down cosine squared x. That fraction is done. But over here, I don't have the correct denominator. So what you do is you multiply the current denominator by what you want it to be, right? Just like you would have done in any other fraction. And don't forget, what you do to the denominator, you have to do to the numerator. So now I have the correct denominator, and my new numerator of this fraction would be sine times sine, with a plus sign, which would be sine squared. Do we see something that can be simplified? Careful. We cannot cancel these. I'm glad you said it, though. You can't simplify these because of the plus sign. If it was multiplied together in the numerator, if that was cosine squared x times sine squared x over sine, I could cancel one of the signs on the top with that one on the bottom, but because of the plus, I can't. There's something else. There's something I told you to always be on the lookout for. Good, Austin. I heard somebody else say it. This is one of your Pythagorean identities. Cosine squared x plus sine squared x, those two added together equal 1. So look how much simplified it got just by remembering that identity. And as I'm working, guys, my eyes are constantly just keeping an eye on what I want this left-hand side to become. And I know that 1 over sine x is cosecant x. Like I told you yesterday, you have to show every step. If on the quiz, and this happens every year I teach it this way, every year I model it exactly the way you're supposed to do it. Every year this is an open note quiz, but every year there are students that take shortcuts and they lose points. And here's a shortcut that I see every time. So don't actually, well, let me write it down there. They'll get to that part that says 1 over sine x, and they'll write that. They'll make this their last line. That's wrong. You have to go all the way down. I need to see that this means this. So now you're done. I don't know when you write this. I mean, you're probably like rolling your eyes at me. Of course I know that this is this or something. But I don't, and the reader doesn't know you necessarily. I mean, I know you, but the reader will definitely not know you this summer when they grade your paper. They want to see the entire thing. So the way I do it is the way it has to be done, right? All right, let's do the hardest one, and then we'll do our last two, which are a lot quicker and easier. Okay, this is dealing with fractions with words. It makes things complicated. I'm clearly going to start with the left-hand side. There's a lot more going on in that. And just because I write so big, I'm just going to rewrite this left-hand side real quick, guys. So just give me 1 second. If you want to, you can too. I just need a little room. But what I hope you notice, taking a look at it, is just like in that last one, we have to somehow make subtraction of these weird little fractions into a single word. Well, that tells me I'm going to have to subtract them. To be able to subtract two fractions, I need a common denominator. Look at your denominators and notice a little bit more complicated than the one we just did. Here, we have two, trig functions, right? I need both of them in my denominator. This is going to be part of my common denominator and this. So just like before, I'm going to set that up with both of those in there. Doesn't matter which one you put first. Doesn't matter at all. But they both have to be there. And so now I'll change my fractions that are in green here so that they have this common denominator. And I'll put the new numerators here, just like we did here. It just has a little bit more going on. So one at a time, let's look at this first fraction. What is this fraction's denominator missing that it needs? Cosine x, right? It doesn't have cosine x. So if I multiply this denominator by cosine x, I also have to multiply the numerator by cosine x. So now the green fraction has the correct denominator, and now we can do cosine times cosine and get cosine squared. So that first fraction is done. Look at your second fraction. In the second fraction, it should have this denominator. It currently does not. It's missing the 1 minus sine x. So I'm going to multiply my denominator by 1 minus sine x. What I do to the denominator, I have to do to the numerator, right? Look what I have to multiply. I have to multiply that. Negative sine x distributed into 1 minus sine x. Guys, I just like to have a little bit of room, so I'm just going to go up here and do it. Negative sine x is on the outside. 1 minus sine x on the inside. Lots of fancy math here. Lots of things you have to think about. We're adding, we're subtracting, we're multiplying. Okay? So I'm just distributing. And I'm going to put my answer right here. Right? I'm just distributing. So negative sine x times 1 is negative sine x, right? Negative sine x times 1. And negative sine x times negative sine x, just like negative x times negative x is positive x squared, negative sine x times negative sine x is positive sine squared x. Okay? Do you need to hear that again? If I did negative x times negative x, that would be positive x squared. If I do negative sine x times negative sine x, that would be positive sine squared x. It's the same thing, just with the sign in front of it. Negative times a negative is positive. X times x is x squared. Okay, we're trying to make this whole thing look like secant. Anybody see something in that numerator we can do? What? We don't have a 1 minus sine x in our numerator yet, right? We just have negative sine x. There's no 1 in front of it. Okay, can you just switch out with me? Keep your answer sheet, sweetie, because you just need 1, 2, 3, and no calculator. Okay. Anybody see it? Same thing as the last problem. I'm teaching you to look for it. We're not looking for it. Cosine squared x plus sine squared x is 1. Remember, 1. Had you already done that step? Okay, that's where. I was wondering why you were saying that, and I kind of figured you might have looked ahead. Okay, so cosine squared x plus sine x, we look for it. It pops up all the time. We just had 2 problems in a row. That just goes away and becomes 1, and then there was still the minus sine x, right? We took those out, became 1, and there was still the minus sine x. Now, remember when Remy a few minutes ago said we could cancel something in the numerator and the denominator? I said we couldn't because it was they had pluses or minuses in front of it. Well, now we do have the situation where we can cancel. This is algebra heavy, knowing what can cancel and what to do with all these things. Like, we can cancel these identical twins in the numerator and the denominator because of the multiplication here, guys. If this had been a plus sign in between those, we wouldn't have been able to do it. Because they're both factors, and those are twins, you're just left with 1 over cosine x, which is secant. So a lot going on there. This is why you want to write every step down and have it in your notes, just in case you need it later. All right, those were the worst ones. The worst is over. Here is C. Write this down. This is actually a 2-step problem, even though it looks pretty gnarly. right, guys. So somehow I have to make the left-hand side look like the right side. I don't see like anything I can factor out. Like there's no GCF there. Something that does stand out to me. So I like to tell you like what I see to help you start. Like you need to train your brain to look for these things, right? And one thing I notice is that if I'm going to make this left side look like the right side, somebody's hanging out over here that's not going to be over there, and that's cosine. There's no cosine in this side. There is sine, so I'm not going to mess with that one yet. Let's see what we could do with this. Cosine squared x is one of my Pythagorean identities. Remember? Cosine squared, now I told you to look for it. It doesn't have to be the right-hand side, it can be the left-hand side. In this case, we're actually going to replace cosine squared x with 1 minus sine squared x. And I know what you're thinking. I know what students are thinking at this point. They're thinking, I would never have known I would never have thought of that. I would never have crossed my mind. We're going to talk about that. So all I did is replace cosine squared x with the other side of the equal sign of that Pythagorean identity, which is 1 minus sine squared x. And I'm just bringing down negative sine squared x. Do you see it? Yeah. So guys, look. If I gave you negative 1 minus 1, what does that equal? Negative 2. What if I gave you negative 1x minus 1x? That would be negative 2x. What if I gave you negative 1 sine x minus 1 sine x? Negative 2 sine x. See the progression? Whenever you see something funky and you're like, I don't know what that is, try to find some place in your brain where you can compare it to something you do know, right? Take the word sine out of that. Then you're looking at this, and then you go, oh, okay, now I just slipped the word sine in where the x is. So that's what you're looking at here. That's negative 1 sine, or sine squared, there's a square there, minus 1. So you get 1 minus 2 sine squared x equals 1 minus 2 sine squared x. Told you, it was a quick one. And I want to address, as we're writing down our last problem, the thought that most students will have at this moment, which is, where's the paper? Something fall. Okay. Let's write this down. Last problem. The thought that comes to mind, whether you're saying it or not, or maybe it hasn't happened yet, but it will, is, well, of course she knows what to do. She's the teacher. She's got the key in front of her. Those are all facts. True. You might think, I won't know what to do on the test or the quiz. I'm not going to know how to start these. Well, first of all, that's one of the reasons I made this an open note quiz. I know that these are challenging. There's some people, you can hear the people in this room where they're clicking for them very quickly. And it doesn't happen for everybody in the beginning. But the more interactions you have with these problems, the easier it becomes. Listening to me, not just copying answers, trying to start them on your own when you get to the homework, not just copying down the homework problems, helps train your brain to know what to look for. For example, in this example here, I see a subtraction sign with stuff on both sides, and there's some common stuff. What's the common stuff? Sin x. This is a GCF problem if I ever saw one. Or maybe it's not. Do you know how many times I've started a problem and thought it was one thing and I couldn't figure out where to go with it, and I back up and start over again and start something else? That happens. But that's why I'm trying to cover lots and lots of examples with you. All right, I'm going to factor out a sin x from both sides of this binomial. Now somehow, so you stop and you look and you say, I've got sin x. I've got 1 sin x. Somehow I have to end up with 3 of them. Sine times sine times sine. Okay, 3 sin x's. So I got 1, so that must must mean that this guy right here has to somehow become a sine squared x. Well, isn't it sine squared x? It's one of your Pythagorean identities. Who did we leave on the other side of the equal sign when we subtracted cosine squared? Sine, yeah, sine squared. So you have the sine x times sine squared x. And x to the first times x to the second is x to the, oops, that's a 3. So before I give you the homework while you finish writing that, here's a suggestion for you. If you feel like you really want to take this seriously and you want more practice, need more practice, here's a suggestion for you. We are doing tons of problems together, yesterday and today. You have tons of examples we did together, homework problems that you know you got right because you looked at the key or whatever. If I were you, I would take some of these, write them on another sheet of paper with room, and try to do them from scratch without me telling you how to start them, without looking at the keys. See if you can come up with that way to start them. Because you do have the key, wherever you got those problems from in your notes or your homework. That's a really good way to have more interactions with the problems, because I'm giving you all the different types you could have, right? All right, homework is on page 150. We've already got some writing on that prop page. No, this. Oh, or write over it, or just use another sheet of paper. And then here you go. No calculator on this video. May and Riley, let me know when you need the other 3 questions. I wrote little notes to you in pink so you could see like a hint about how I knew what to do to start you. Work together, ask me for help. 4 problems. Sorry, 8 through 10, 14. 8 through 10, comma 14. This is D2. Okay, just keep the calculator at the side. Mm-hmm. I changed cosine to cosine over sine. Yeah. Identities, yep. Remember yesterday we did that? No, I did not. Because it's the Pythagorean theorem. It's just a squared plus b squared equals c squared. That's all that is. Just written in trig language, right? Cosine is x, sine is y, and your radius is 1. Because it's a unit circle. That's where the 1 comes from.